Okay, so I've been led to believe that you have to give some talks. And so this presentation is something that I created because as faculty members, we work pretty hard in helping our students give talks. So if Michael's students go present at Chi, my students go present at SIGGRAPH, there might be a 15-minute talk and there might be a week and a half of prep before that talk or more. And I kind of felt like I was saying the same thing all the time. And so I was like, okay, maybe I should write some of this down and we can create a reference for my students or for you. So that was my motivation for making this talk, and I gave it, and it's been helpful a few times. I tend to give it actually in the second to last lecture in a lot of my courses before there's project presentations, and I found that undergraduates actually listen to a lot of these rules a lot more so than graduate students. And so they seem to be effective for at least some populations. So I would think about this. This is not a talk that's do this, do this, do this. This is just a talk of anecdotes that I find work well for me. Okay, so let's just get started. So to get started, I think it's always good to establish why do we give talks? I mean, why are you responsible for giving a talk at the end of this class? Or why is the primary content in any computer science conference usually a bunch of talks? I mean, is it a chore? Is it a social obligation? Is it like, why are we having you talk in this course? I'm curious what you think, because if you don't know why you're doing something, it's kind of unclear how well it's going to go. Yes, ma'am.
Sometimes concepts are more easily and quickly communicated via verbally versus doing it by through reading.
I agree with that. Yeah. So sometimes just some stuff is just easier to give in a talk. Like in a talk, I can wave my hand. You can understand the magnitude to which I care. Or often in an interactive talk setting, you can ask a clarification question and we can iterate towards some form of shared understanding. So in some sense, a talk is a different medium than a paper, in the same way that radio is a different medium from TV or texting is a different medium from sending an email. It definitely serves different purposes. Yeah. Okay.
Just like it opens up the opportunity for an interactive conversation where you can kind of explain on things that weren't present or weren't as clear.
So you can expand on things that and actually in some sense some bars for talks are actually lower, right? Like if I write a paper, I have to be thinking about, this person's not going to be able to interact with me. I have to anticipate all possible confusion points. In some ways, giving a talk is much easier than writing a paper, and in some ways, it's incredibly much harder. Why else do we give talks? We give a lot of talks. Now, not all of those talks involve a lot of back and forth. Like if you go to a conference, like somebody might give a talk, or you might go to a webinar or something, and there's not a lot of opportunity to have interaction with that speaker, but we still give talks.
Yeah. I think this is also owing to the fact that it's a different medium. Is that with the talk, one, it's more personalized, or at least it's more human, and so you feel like you're interacting with a person. Mm-hmm. And when it comes to a talk, I feel like it's also easier to get excited about something than it is to get excited about reading a article in a journal. And so perhaps a talk is mainly for stoking interest rather than actually communicating the content of the paper.
Okay, so the idea is that there's like some excitement about a talk. In some sense, a good talk is kind of like an event. Like I want to go hear what Michael has to say, and I haven't run into him in a year or something like that. So there's definitely the notion of building excitement. I would say that there's still like it would be a shame if I didn't communicate any technical content. It's still a big opportunity. Any other thoughts?
The professor's forcing us.
Yeah, exactly. Like one reason why you give a talk is it's part of your grade.
I hate the professor.
Yeah. That's definitely, it seems like that's the attitude of some speakers. Any other thoughts? Okay, so there's one way to think about this. And one is I like to think about talks, like I like to think about talks either selfishly or as a service. If I want to think about the talk selfishly, I have the opportunity to talk to all of you that are smart people that might have different perspectives than me, that might have something to add. And maybe you can provide me something that I didn't know. So if I put you in a position to help me, I all of a sudden just have the attention of 20 really smart people, maybe 100 really smart people, maybe the entire field at a conference like SIGGRAPH or Chi. And you better think about that as a big selfish opportunity to put everybody else in the position to help you achieve your future goals. Because you're probably doing research because you're really into something and you want to make progress, you want to advance the field. Put people in a position to help you. And that is actually number 2 on my list, right? Number 1 on my list is I think about talks like service. All of you have taken time out of your day to sit down. And if you go to Chi, you go to SIGGRAPH, you go to CVPR, a huge fraction of the field has taken the opportunity to sit down. And you have the opportunity, given that you've been working on some research project for long enough and have been digging into these details that nobody else is digging into, to not tell people what you did, but what you found out that you think would be useful for them to know. Right? So I like to think about, when I start a talk, I'm like, what is the most good I could do to the field in what I'm going to present today? What do they really need to hear?
So would it be fair to say the paper becomes like an academic artifact that has to prove itself, but the talk does not? The paper is in. If you want to see all the details, you can go to the paper. The talk can be whatever I think I need to convey to you.
Yeah, exactly. Like in some sense, the reason why you're being invited to talk to that conference is people have said that you've done some really good work. You've written it up. We've checked the validity of it. We think it's scientifically valid. We think it's interesting. We'd like to get your perspective. Now, some of that perspective is to talk a little bit about the work that you did and stuff like that, but it's also to expand on that and say, hey, given all this detail that I've put in, I'd like to provide the service today of saving you all the time of making all the mistakes that I made or this and that. Okay. So bad reasons to give the talks are, I think a lot of people go to conferences thinking getting up there on the stage is a reward for getting a paper in. Right? They love the fact that everybody comes up and says great talk afterwards, regardless of whether or not the talk is great or not. It is not a reward for getting a paper accepted. It's not punishment for being in a class. It's not an obligation. It's an opportunity. And so I think if we just start thinking about talks as opportunities, a lot of people will take it a lot more seriously, and then they'll produce better talks. And again, going back to the selfish point, think of the number of person hours that are here in the lecture today. We got about 25 people here. We're talking for about an hour. Shoot, if I waste 25 person hours of time, that's quite a big disservice to all of you. I'm sure you would love to have 25 hours back this week, right? And to me, it's a missed opportunity if I don't do a good job, because folks like, some graduate students up in the audience, and I'm like, wow, they really had some insight. They were really clear. That's going to make me go up to them and maybe want to learn more or remember them. Or the next time they come around looking for a job, I'm like, yeah, that was that person that really did that really nice job. It's super, super insightful. Hey, you looking for a postdoc or something like that? That's how opportunities arise. So there's this kind of non-linear benefit to giving a good talk that goes beyond people reading that paper, people building upon your research. Okay, so the rest of this talk is just going to be a list of principles that I like to use that I kind of hadn't seen written down very much, and I'd like to share them with you. So let's get started here. And does anybody know who painted this painting? Look familiar? Any guesses? Go back to your Waze courses. No guesses? It's actually kind of a hard one, actually. It's Dali at age 22. He was actually a pretty good realist, still life painter, well before he started making paintings that look like this. So I break the rules in this talk all the time. My students break the rules in this talk all the time. Learn the rules, and then you can break them intentionally. So that's sort of my, like you can probably raise your hand and say, Kayvon, I saw this PDF online of this talk from your students, and I know. Okay, so tip number one. So tip number one at first sounds pretty obvious. You need to identify your audience. But what percentage of, let's say I go to a conference and I give a talk, what percentage of the audience do I expect to understand what I'm saying? What do you think? I mean, what's the number? I've heard people advise people to say, make sure that 20% of your talk or 5% of your talk or whatever like flies over most people's heads because it'll make you look smart. I have heard this advice from fairly reputable people. What do you think though? Like if you're going to go give a talk, what is your goal on what fraction of it should be understood by your audience? What's a reasonable goal? 100%. 100%? Any other suggestions? I like the 100% number because if I'm not aiming for 100% understanding, I'm like saying, I'm going to say some things that I know that most people won't understand. Why would I say that? So my first thing that I do, and this is probably the hardest thing to do, is to pick who you're talking to, get yourself in their shoes and go, if this is a person that hasn't been in my lab for the last year and a half and hasn't been in all the conversations about the paper, what do they want to hear and what will they be able to actually understand? And so my view on this is you should go for 100% understanding, right? You want to push it. You want the most technical material you can get in there, but largely aim for 100% understanding of the people that you really are trying to speak to that day. Okay. So this is hard. And I think especially for people that are just giving their first talks, being able to put yourself in the shoes of other audience members is probably the hardest skill. Like most of the time, like students are practicing a talk and I'm like, there's no way that anybody's going to understand that because they don't have X, Y, Z, A, B, C. There's so much context in your head that you're assuming. Okay? So this just requires some practice. But one thing that I actually, for whatever reason, find helpful is when I say something out loud, it kind of disembodies me a little bit. I can call bullshit on myself a little bit better if I hear it out loud. So sometimes I'll be walking around the room and I'll actually try and say what I think I'm going to say over a slide, and I'm going to go, yeah, nobody's going to get that. So that's I want us to keep in mind that we're going for 100% understanding in all of our talks as a starting point. Now, another version of saying the exact same thing is if you're trying to get everybody to understand everything, take out anything that can't get understood. So one of the most useful thing that somebody ever told me in giving a talk is figure out what you want to say and then just say that and don't say anything else. So I'm always asking myself, what is the point I'm trying to make? I'm trying to convince someone that my data supports this hypothesis. And then I ask myself, are the words in my speaker's notes and the words on my slide making that point? If not, I take them out. And that's it. Like that's like the number 2 rule that I use in all my talks of what is the point I'm trying to make here? Would a reasonable person come to that conclusion if I said this? And if the answer is no, I take it out. And let me give you an example of this idea that I often say of every sentence matters. The intro and backgrounds of most people's talks, and then in fact, actually, I imagine you're going to start creating some related work, some introductions and things like that, is one of the most important parts of a talk. Okay, and too many talks blow the introduction and related work, in my opinion. Okay, so the goal of the related work in a paper is to be comprehensive, is to give the reader the ability to go back through 100 years of literature and go find the papers that are the most relevant, give you all the background you need. The goal of the related work and background in a talk, because like you all said, it's a different medium, is totally different. It's what I'm putting right here, is today and only for the next 50 minutes, here's how I want you to think about the problem that I'm going to solve. I'm trying to establish shared context amongst all of us. Because if I'm up here speaking, the way that I think about the problem that I'm trying to solve, I think will be helpful to you. And that's why I'm up here giving this talk. So let me give you a bad example. And for those that in the future ever watch this on YouTube, I apologize because I pulled these off other people's slides and they know it and they're cool. I see a lot of talks that begin with something like this. What is this telling me? This is telling me that there will be an introduction to this talk. This is telling me that this talk will have a results section and a conclusion. 20 seconds just got burned on this outline. and I learn no additional information as a listener. Okay. Here's another version that we see all the time, some related work slides. So this was from a computer graphics talk from a popular paper, and it doesn't matter what the topic was, but this talk decided to spend a slide to list a bunch of things that are related, and then list a bunch more things that are related. So let's take a step back and say, what's the point here? What am I trying to do by saying this? If I list a bunch of papers, I'm basically saying to experts, other people that you know about this work and other people have done it before. And does that help them? Because I think most people assume that people have done work related to what you've done before. And imagine it's a novice audience, someone that's not familiar with all this fancy stuff. Do you expect them to learn all that stuff from just 2 slides and a list of figures and things like that? So what am I trying to do? I'm trying to get people to think about the problem the way I think about it so that they get my solution. So that's what I got to do in the intro. This is like taking a paper and shoving it in a talk. You had a question? Oh, that was a stretch? Okay, yeah, okay. So here we go. How do I get people to want to adopt the way I think about things? And a nice little trick is to catch everybody's attention, because a lot of people in the intro slides are looking down, and they say when they actually get to the meat, I'll look up, especially at a conference. Is most people respond to going, I think I know a lot about this, but wait a minute, like that person just told me something that I thought I knew and I don't know. Like I thought I knew everything about this field and this was good, but they just asked me a question that I can't quite answer. Now I'm interested because I'm a little embarrassed about that. So let's think about this. So here's an example from one of my papers. Again, the paper does not matter. Okay. And some of you might be doing some machine learning projects. So the main principle of the paper was, seems like we should be able to train a machine learning model to do computer vision to pick out cars or whatever if the only thing we did was have this one camera viewpoint. Seems like it'd be pretty possible, right? Like one camera viewpoint's not all of ImageNet. Seems like it should be easy, right? Okay, so this is what my traffic camera sees. There you go, it's moving. Okay. But even from a single traffic camera, it can actually get a little tricky, right? Because this intersection has different cars. It has different weather conditions. There are different intersections. And so, you might see some different things even in that. So what would you do next if you're a machine learning researcher? You would say, I need to make sure I go curate a data set of all the different seasons and all the different cars and stuff like that. So if I just had the big, nicely curated data set, still, supervised learning should be a problem that we can handle. Okay. And so then I said, but my students did this experiment where they took a lot of training data from like the last year and then tried to train a model and work on tomorrow. And then they decided not to take the last year, but only took the last week and trained on tomorrow. And then they took the last 5 minutes and trained on tomorrow. And which one do you think worked best? Oh, sorry, I missed it. Yeah, so I missed the build, right? So this one worked best, right? And so it kind of makes sense, right? Like the last 5 minutes are really indicative of the next 5 minutes, and so overfitting can occur and stuff like that. So given this experiment, we started thinking like, why are we doing machine learning on big general data sets where you have to work really hard to get the right data set and predict everything that happens? Why don't we start just retraining models on the fly every 3 or 4 every 5 minutes to adjust to the world as it happens? And that's something that makes the audience go, I don't know. I don't really do that very often. Maybe I should put down my laptop and listen to this thing, right? So that's basically the reaction of, and then they'd be like, well, the reason why we don't do that is because I don't know how to retrain the model every 5 minutes, or I don't know where to get the training data. That's really hard. And at that point, you've got them. They're like, oh, that's the point of the talk, because if they have an answer to this, I'd be really interested. Okay. So, and then I can say, yeah, other people have kind of seen a problem like this. There's these people off in Chelsea's lab, meta learning to try and redo these models, and there's these other models over there. And now all of a sudden that laundry list of things makes sense because I've said, here's how you think about everything in this area in the context of this framing that I think is really valuable, which is, why are we doing general purpose machine learning? Why don't we just overfit to everything? So those are the kind of intros that are really, really valuable. It makes people put the markers down or the laptops down. And it's largely of, this person posed a problem that I cannot answer. That's interesting. Let me listen some more. Okay. Random tip number 3. Too many people, and many of you are computer scientists. Computer scientists like to think in terms of inputs, outputs, and constraints on solutions. And folks are often very shy to just state that. So you can go no wrong in a talk if you state your problem definition in terms of, these are the inputs, these are the outputs, and these are the constraints that I had to abide by in my solution. Those constraints might be very systemsy. It's got to run in real time. It's got to scale to 1,000 processors. They could be algorithmic, like I need an O of N solution. They can be social, like it is inappropriate to do this, so we cannot invade privacy in this way. We have to go another direction. So establishing the constraints and the inputs and outputs is super, super helpful to your audience, because your solution is going to be judged by how well they met the constraints or met these goals. And so if I know the inputs, the outputs, and what it means for things to be good, as a listener, I can just kind of nod my head a little bit as you start telling me my solution, because now I'm listening, comparing your solution to what you said was our definition of good. So this is, some of these things in this talk are actually hard, like setting up the intro properly, that's hard. This one is easy. Don't mess this up. Like this is like nuts and bolts. Okay, so you start doing this, then I would say, make your life easy. Show people things. Don't tell them what you mean by that. So let me show you. Like, it's much easier, and especially in my neck of the woods, to use pictures and videos or sound clips than it ever is to try and explain something in words. So let me give you an example. This is something that, like, I help with talks all the time. I'll see a student put down some description like this. Like, let's see, what was it? Given enough video of tennis matches of a professional athlete, could we come up with an algorithm for turning all this input video into a computer game character? You can kind of maybe understand what I'm saying, but you have a lot of questions like, well, what do you mean by input video? What do you mean by a video game character? What do you mean by this? What do you mean by that? And our colleague Manish Agrawala is famous for asking the question, what do you mean by that? And it can be kind of annoying to people on the other side of that, because like, it's kind of like, what do you mean? Are you saying I don't know what I'm talking about? And really what we're saying is, as an audience, we want to be precise about what your inputs and your outputs are so we can understand what's going on. So let me give you, a better way than this. And it's really easy. I don't have to memorize any words. I can say, so the inputs to my problem are a bunch of tennis videos. I'm going to play one for you. Here's an example of a tennis video. And all of you just went like this. Like, you said, yeah, I agree. That's a tennis video. I am following the talk. I'm proud of myself. I'm doing what I'm supposed to be doing, right? So this is a tennis video. And there's a lot of tennis videos. And you're like, yep, I see it. There's a lot of tennis videos here. And I'm following the talk. And so what we like to be able to do is put all this stuff in a computer and output a computer game character that responds to some control input, right? So what does he mean by that? Well, here's an example of that output where we're controlling this guy here and making him hit the ball to the red dot and move back to the blue dot after he hits the ball. And you're watching this video and you're going, yeah, I can see that. Okay, I know exactly what we mean by what the output of the system is. And now your head is actively participating. It's going, well, how do they do that? How would I take all that video data and get it into this thing? Okay, just give you another example. Okay, so all those different videos were actually taken on different days under different lighting conditions. And so we had this problem of how do you kind of normalize all the different lighting conditions. So you, a reasonable listener, is probably going, well, what is it? What do the different lighting conditions look like? You know, like how hard is this problem? I didn't need to say any of that. I should just say, well, all those videos were taken on different days. And as you can see, every box here is a different frame and a different time of the match or a different day. And as you can see, like they're under pretty different lighting conditions. And you're like, yeah, I can see that. Like I'm cool. Like I'm definitely understanding everything he's putting out there. And that we need to make sure that we normalize them so that they look similar. What do you mean by look similar? Let me just show you what the output should be. So I'm setting up the whole thing of here's the input, here's the output, and we got to go from A to B. Another project recently, we were designing a computer game engine that has to simulate thousands of different worlds at the same time. It's actually for reinforcement learning where we want to train a robot on thousands of things. Well, what do you mean by simulating a bunch of things at the same time? Well, here's an example of the output of the system. Like we're actually taking a robot through 1,000 different worlds at the same time. Or maybe in computer vision, we have a classification problem that's really fine-grained classification. It's not like dogs versus cats. It's about identifying certain species compared to other similar species. And just to give you a sense of how hard this is, each row here is a positive example of the species, and here are a bunch of negative examples of the species. And as you can see, it's probably pretty hard for all of you in the audience to tell the difference between the leftmost column and the other columns to the right, and that's evidence of the difficulty of the problem. So making people feel the inputs and outputs is probably one of the other things that you can do that's super easy and makes so much of a difference in the talk. Okay, let's take a deep breath here for a second. Any thoughts, questions, disagreements? Yes, sir.
I definitely felt the show on telephone very viscerally. Like it was so much easier to understand what was going on compared to the description. When you actually had the video frames and stuff like that. Which I think also the project itself lends itself well to a visual description.
Some of it, yeah, some projects definitely do, but you'd be surprised how many do. Even like a hardcore systems project, you can do it with diagrams. Almost always. You can almost always do it with diagrams. But it's true in graphics and some of the more media-centric fields, it's a little bit easier than others. Now, by the way, my slides here actually have way more text than I would ever give in a talk, and that's because these are actually meant to be archival for people reading after the fact. So if I gave like a conference talk, you would be hard-pressed to see more than a few words on every slide, actually. Yeah.
What you showed from the earlier is that you want the audience to think about the idea and not wait for the duration of the talk. Is that not something that you want them to like carry away with them as well?
Absolutely, because my claim most of the time is, or at least in theory, in computer science theory, the problems are all like pretty well established, and you got to be pretty smart to solve them. In a lot of other areas of computer science, and to be honest, most of machine learning is like that these days. It's actually like a unique perspective on the problem is the kind of the key insight. And like once you have that perspective, it kind of gives it away. It's pretty easy to solve. Like computer systems, you're like, you just got to put a queue there. You're like, oh yeah, okay. Or you use a stack. And so usually it really is this framing that is, remember, a talk is service. I'm trying to impart some knowledge to you that you can take away and use to your problem. And your problem is probably different than my problem. And so the question is, can I give you a framing of how to think about things that maybe you, given your own perspective, your own knowledge, your own background on the details of your problem, you can orient that framing towards your solution. If I just give you the facts, I'm leaving it up to you to make that connection. And I'm trying to do the hard part for you. I'm trying to tee the connection up for you so you can take it and run with it. Right? And so, and it just makes it easier when someone says, what was that talk about? You'd love to say it's about this high level thing that I learned and not about the improved performance on this thing by 25%. Yeah.
So you made it pretty clear that like diagrams are better than words. But what about with math? I have like a system that can be described with like an equation or like a diagram. Should I do like the equation or the diagram?
I mean, I think some of the most beautiful math talks that I've ever seen were fairly low on equations, actually, and they were extremely technical talks. But you're going to need to use equations. But in SIGGRAPH, we have papers that are full of math, and the talks often are actually like, here's the one equation, or things like that. Or maybe you'll flash a slide and say, here are all the equations. And the technique is not meant to have anybody understand it. It's meant to demonstrate that there is a proof or is math behind it. Please go look at the paper or something like that. So again, it's like this 100% understanding thing, right? Like if you only have 15 minutes to give a talk, you can't be waiting for people to read a slide or parsing an equation. So you have to be very judicious about what equations you do show. The same way, like if it's an algorithms talk, like the pseudocode you show it's got to be limited. And I think both of your questions were very relevant to bringing up my favorite tip, which is the audience prefers not to think, or at least not to think much. And really what I mean is they don't want to think about certain things. So my claim is that the audience has a finite amount of mental effort that they're willing to spend in the 50 minutes that you're talking, okay? They don't want to burn that mental effort on things that you can just tell them. And I'll give you some examples. They want to burn that mental effort on, do I buy the premise? Do I think this experiment is sound? How will this relate to me? What connections is the speaker missing? They don't want to be, what's the x-axis of the graph? What do you mean by different lighting conditions? They just want to be told that and not think, okay? So one way to, the next couple slides are all going to be about examples of you don't want to think. I know you don't want to think. And as a listener, I don't want to be thinking about stuff that I don't have to be thinking. Is what you definitely don't want to be thinking about as an audience member is why the speaker is telling you something. You always say why you are about to tell them something before you tell it to them. And then often after you tell it to them, you go back and say, this is why I told that to you. So it's like, here's what I'm going to tell you and why. I tell it to you. And then I say, the thing I just told you, remember, I told you for this reason. Okay, so that leads me to surprises are bad in a talk. Surprising results, good. Surprises in the narrative, very bad. Okay, so giving the why before the what gives you context for why you are burning your energy to listen to me. So for example, it allows you to compartmentalize. Oh, he's giving me details about the problem setup because I need to know that to understand the solution. Or he's giving me a way to come up with a loss function because we have an optimization problem, right? Knowing why we're doing something allows you to compartmentalize. If you get lost, you go, I don't know what the heck that solution was, but I know all they were trying to do was trying to optimize that function. Great, I'll go figure it out later. Okay? So in the algorithm description, you're going to use phrases like, we first need to establish some terminology. And you'll see your listeners go, yeah. Like, I would like to establish some terminology. Thanks for doing that. Or given X, the problem we still haven't solved is Y. And you're like, shit, I didn't think about that. We haven't solved Y yet. Thank you for telling me that. Like, those are the types of things, right? Like, so here's a slide from one of my students' talks a long time ago, where we went to the evaluation section. I didn't show graphs. We had the student say, if you're going to evaluate my work, you should be really worried about these two things. And you're like, those are pretty good questions. Thanks. I didn't have to bother thinking of any questions right now. Let's go see if you got the answers to those questions. I want to see your graphs. So that's how you got to set things up, right? And so it means that big surprises in a narrative are bad. So when I'm practicing a talk, especially if I'm giving an important one, if I forget what my next slide is, it's a sign I've screwed something up. Like by the time I'm ready with my talk, I don't need my speaker's notes. I don't need anything because it's all just kind of set up into, let me tell you why we're going to do something. And then it's easy for me to just say the next thing. If I go, well, oh yeah, it was tip 7. I'm like, ooh, I have messed up a connection and I have not said why because I got lost. Imagine what my audience is like. So I think that's a good signal, a little yellow flag in your talk as you're talking. If you're like, what am I supposed to talk about next? You've missed something. You've missed something. Okay, so why before what is don't let other people have to think about why is he telling me this? Why is she telling me this? And so on. The other version of don't think is always, always, always explain every figure or graph and explain it to your audience like they're 6. Okay? So let me give you an example of that. Because you do not want to spend time understanding what this figure is. This is a figure from one of my papers, right? Don't care. But if I'm going to put this on the screen, I have to explain it to you, and I have to explain it to you like you're 6. So let me tell you how to explain this figure, which is, again, for a talk that doesn't matter what it's about. What I'm showing you here is I'm showing you a pixel grid. So this is an image, and the squares are pixels. And I'm showing you a triangle that we're trying to draw onto the screen, okay? So half of you just nodded. You're like, yeah, that's a triangle. I'm following, this is rad, right? And then I go, okay, and the dots are the places where we're gonna compute whether we're inside the triangle or not. And again, because you're 6, I'm gonna be like, and notice that the red dots, those are the ones within the side of the triangle. And all of you are like, yep, they are inside the triangle. Like I am completely following right now, okay? Here's another example of that in another thing. Is here I'm rendering 2 triangles, and I'm coloring the triangles based on the amount of work that happens in a box because of the triangle, okay? And it's a heat map. So as you can see, a good phrase is as you can see, because it's telling everybody, look at the diagram and verify what I'm about to say. As you can see, on the boundary between the 2 triangles, it's lighter colored, so there must be more work going on there. You don't have any idea what this actual figure was about, but you understand the point, which I'm trying to highlight. There's more work here. Okay. And this applies to graphs in your results section as well. So if you put up a graph, you've got to explain the graph. Okay. So here's an example of a graph. There are 2 lines on it. This was a graph. We were trying to figure out the relative efficiency of these 2 lines as a function of the size of something, in this case, the size of the triangles. So the x-axis of the graph is the size or the area of the triangle. The y-axis is the amount of work done for 2 different algorithms. And as you can see, the red algorithm becomes a lot more inefficient compared to the yellow algorithm at the low end. And I saw several people nod. They're like, yep, I agree with that conclusion because the data bears it out. Okay? And that's like an example of this. Now, sometimes I can actually give you a y first. Might be a good idea in front of this graph. Like, okay, let me tell you how much more efficient it is at the small triangle size. So here's a graph that shows you that. So you know the y. And now I'm orienting you through the data. And just for the sake of time, I had some more examples. I'm going to skip this one. Okay. Okay. Only say what matters, remember? So tip 8 is figure out what you want to say and just say that. So when you are doing results, the point that you are trying to make with the data that you are showing, the conclusion, the surprise, whatever, is the point of that slide. It should be the title of the slide. Okay, so the audience doesn't want to think about what they should be concluding from the data. So I'm going to tell you what you should be concluding from the data at the very top. It's the first thing your eyes see before I almost even open my mouth to talk about the slide. So the point here is I wanted to show that my system scales linearly with the number of GPUs, or in other words, this graph should be a line. And as you can see, as we increase the number of GPUs, the performance goes up almost as a line. It scales linearly. And you knew all along that that's what we were trying to get to because the point is the title of the slide. Here's another example. Algorithm A uses 2 times less resources than algorithm B. And if we look at the graph, algorithm A is blue, algorithm B is yellow. And as you can see from all of the data points, one algorithm is about half the resources of the other. So you know what I'm concluding up front. You're not worried about where are we going with this. And I'm walking you through the scientific data so that you can conclude on your own that you agree with my conclusion. Here are a few more examples. And like these titles are long. You know, they're almost full sentences sometimes. They're full phrases. And that's okay. That's completely okay. Now, one little corollary, I think this is probably, I should have taken this out today, I apologize, is often people like to cut and paste figures from their papers into talks. Figures in a paper often have to make a bunch of points because there's limited space or you're going to talk to it in different sections. Figures in a slide need to make one point. Like if I have a second point to make, I'm going to make a whole new slide. I'm going to change the title of the slide, and I'm going to remove any visual data that's not relevant to that point. So in the same way of if you're saying something that doesn't make the point, don't say it. If there's something visually on the slide that's not related to the point, you got to get rid of it. And it means that you're going to have to recut all your figures for a talk, and it stinks, but you do. You definitely do. Now, here are some examples of some slides that I pulled from a conference that I attend, and look at the titles. The titles are like, these are results, okay? And, you know, we do this all the time. It's okay, but the title is the most important part of the slide. Why we did this experiment is the most important thing that you could take away with. And we're throwing away the most important visual real estate on something that's a no-op. Like you might be like, what am I supposed to conclude from this? This could actually be a great graph. I don't know, but I don't know what I should conclude from that. All right, almost done here. So tip 9 is that almost what I just said. In general, it's not just for the results slides. Titles matter. And the easiest way for you to sort of give people the context of why you're telling them that in advance is just to put the main point on the title of the slide. Whether it's a methods figure or an algorithm figure. Here I was talking about how something's an approximation. Well, the title of the slide is this algorithm is an approximation to this. Or if I want to say that, like I'm trying to state a fact, the fact is the title of the slide. And it has this nice property where if in Keynote or PowerPoint, you go into that little like slide sorter, like whatever it's called view, like the thumbnail view, shoot, you actually have almost an outline of your talk if you just read the titles. So make your title font big enough so you can read it. And you actually kind of see the structure of the whole talk all at once from the title slide, from the section slides, or sorry, from the titles of the slides. All right. Tip 10, give yourself a break. If you look at this talk, there's a bunch of slides in it that just have like one line of text, which is kind of like a chapter or a subject title. It's great because when you do this, you are clearly signaling to everybody. You know, your talks here might be a little short for that, but you clearly signal to everybody, hey, like, we're taking a break. We're moving on to something else. It's the chance for you to relax, to other people to say, I didn't understand any of that, but now we're back on the rails. It's just a very, very helpful for all of you. It's where you grab your water. You take a drink, you act casual, you feel like you're not nervous, that kind of stuff, okay? All right, last one is, and on a positive note, that was actually something I learned very late in my career, is many talks are like, well, we had this algorithm and the next thing is to make it 15% better or to extend it to this other data set, or now we need to, we did it on cats and now we need to do it on dogs. It's just kind of boring, right? Like you're trying to inspire people, you're trying to get people interested in what you're going to do. So come up with something to the people to walk away from and that makes the rest of the world go, hey, you're really onto something. You're really onto something. So like my final SIG graph, this slide took me 2 days to come up with in my last talk as a PhD student, which was like the summary of all of my work. And I was like, hey, we've been all trying to do like Pixar quality graphics, and we've worked out some of the algorithms here, and I think it's not that far away. I think we're on the verge of something. And some people in the audience that were some bigger names in graphics were like, oh, I kind of get I've never seen that guy's work, but I kind of see what he's doing, and then why it's relevant to all of us. Okay, so last thing, and then I'll stop. Tip 12, you're going to get feedback. When you get feedback, the customer is always right. Because your goal is 100% clarity. If it wasn't clear, you failed to meet that goal. So when someone says, I didn't understand this, your temptation is to get defensive. So you go, oh, no, I said that. Click back right here on the slide. That's what I said, right? And really what you should be saying is, okay, back on the slide, I was trying to make a point here, and this is how I thought about saying it. is there anything I could have said differently that would have made you understand? And the flip side is that if you're giving feedback, you can't be like, this is so unclear. You have to say, this is why I was confused. Okay, so we're at time. I'll just leave this up, those are just some tips. Maybe you got 2 or 3 of them. I think you'll be in good shape. All right, so we can turn the camera off, or we can not turn the camera off, and we can or cut the video, I guess, at this point. And
yeah, let's start by thanking Kayvon.
All right, fair enough.
If you gotta go, go.
If you gotta go, by all means.
If you want to go.
By all, if you want to go.
We have some time.
We can hang out at the end of the day.
If you've got questions, thoughts. One thing that comes up, I'll just to kick this off, is they've got 5 minutes to give a talk. So there's this temptation to give a talk by taking your paper, grabbing the like resize handles and go and just like sort of basically just making a smaller version of the paper. But that tends not to work because you can't literally fit it into 5 minutes by just making things smaller. So when you have to give a short talk on a big paper, what do you do?
I think if I had to distill it into the principles, it's if you say that everybody has to understand everything I'm going to say, you clearly just can't talk faster because and you can't possibly talk about everything that you did. So the question is, I have 5 minutes. What's the most important thing I can say? And what do I need to say in order to make that point and no more? So step 1 is figure out what is that 1 point or maybe 2 points. Like that's all you got. And I think in a 5-minute talk, it largely is usually what is the problem? Why is it hard? And what's the one little insight amongst my conclusion? And one insight on my approach or solution. So what is the problem is best done visually, if you can. So here are the inputs, here are the outputs, here's the one constraint. And then there's my approach, the thing that's pretty interesting about my approach is this. And that's about all you got in 5 minutes. 5 minutes is hard. 5 minutes is really hard. Yeah, it's very much about how do you scope what you want to say to the thing that matters. And also it's about what your audience wants. Like, what do you want to have happen, right? Is the goal to motivate other people to come talk to you at your poster? So then you're not really even trying to give much about the solution as much as here's an interesting problem and I want to talk to everybody that has similar problems. If what you're really interested in is the solution strategy, maybe you focus on solution because you want all the reinforcement learning people in the room to come talk to you, even if they don't care about what you're applying it for. So it all starts with who am I talking to, and what is the 100% thing that they can understand, in my opinion.
In actual conferences and especially top conferences within computer science, what's the norm for the presentation format? I think you mentioned it was 15 minutes.
It's pretty different nowadays, and in fact, it's kind of been shrinking. I think it used to be kind of 20 minutes plus questions. I think in most conferences these days, if you are allowed to, if you're privileged to give a talk, it usually is about 15 minutes plus questions for the spotlight or the papers that are given the longest floor. In other situations now, it's almost down to 5 or 8 minutes in a lot of conferences. Like SIGGRAPH last year, they did this thing where everybody talked for, I think it was 8 minutes. And then everybody split to different corners of the room and it turned into a poster session. So the 8 minutes was largely your goal was to say, here is the one little trick that I figured out. Come talk to me if you want to learn more about the trick. So yeah, it was very similar to this 5-minute talk that you're talking about. I think it was 8 minutes.
Yeah, WISC this year, each paper got 15 minutes total. So it was 12-minute talk plus 3 minutes Q&A. Part of the problem is that these conferences that were built for a smaller computer science have grown and grown and grown and grown and grown, and they don't want to have a 7-day-long conference. So they multi-track and then they make the talk shorter.
Yes.
This is pretty closely related, but for both of you guys, what has been one of the most impactful or one of your favorite talks that you've heard at a conference?
Oh, gosh. Great question. I don't know though.
I can tell you one of the most impactful moments in a talk I've seen. Sometimes I work backwards. I got this phrase from Scott Clemmer talking about what's the beer moment in your talk, which is to say, what's the moment that people are going to discuss over beers that night? Be like, did you see the moment? Okay, so there was a talk that Chris Harrison was giving at Kai, where he's trying to say, could we do on-body interaction where we can detect anywhere on your body that like where you're tapping, and you could use that to like sort of command your phone, even if your phone's not out. It's sort of like there's this versus this versus this, etc. Okay, so that's the problem. And his point is, look, actually, when you tap your body, you sort of vibrate the internals of your body in a way that you can sort of triangulate, like you'd be able to triangulate an earthquake. But the way that he proves this is he takes a high-speed camera and takes a video of himself doing this, and then you see his body going whoop, 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 whoop. You know, you see the vibrations moving outwards. And you're like, I get it. Yeah. That's brilliant. So there was just this moment that conveyed an insight that was just like changed how you saw the world.
Yeah, exactly.
In a kind of creepy way.
I'm not sure. I'm not sure if a concrete example comes to mind right now, but those are always the moments where people are like, "Whoa, that was like the world is different to me now than it was before I saw that example." And that's good work when you do that.
Yeah, I often design outwards from what that sort of peak of the talk is supposed to be. You know what's the big insight you're trying to convey or what the big result is that's going to amaze people. I just work backwards for how do you build up to that and then how do you come down from it.
Yeah, I think a lot of people fall into this trap, and I do it too, even to this day, is if you've worked on something for so long, you tend to focus accidentally on how you got there and everything that you did. And the talk is actually about, you have to divorce yourself from that and say, here's what I think my audience should know, or here's what I figured out from that. And sometimes like people are like, well, there was this really interesting process that got me to where I am today or to this result. And usually that process is not all that helpful to everybody else. I mean, it's helpful to maybe young researchers to understand the process, but it's like, yeah, okay, fine. You came at it from that point, but at the end of the day, what you really figured out is this. And that's what I'm going to take away from it as a listener and sort of identifying the essence of what you've done. That is the really useful thing, I think. Yeah. Yes.
So in terms of like the motivation / introduction for your project, is it okay if like it's more of an informal / personal like
sure.
anecdote for it? Because I think like with HCI particularly, it tends to be like sometimes it's more like what the individual person would rather experience versus what like the trends have been and how those have shortcomings. So I guess like, yeah. Like,
I agree, and I would just it's the principle is say something that has value. And what I mean by that is, let's take a graphics one. Like, so in graphics, like realistic rendering, blah, 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 right? Like, so how many graphics talks have we seen where the person decided to spend their first slide talking about the value or the merits of realistic rendering? Because it's an advance in realistic rendering. You're like, it's completely unnecessary.
They're like 20 of these in computer science. Yeah. Like, networks are getting larger. Mm-hmm. We're getting more and more data, and we must crunch it.
Yeah, exactly. That's good for the first person that says that, right? Because that's like oriented the community about, oh, it is about the data. Like that's like a transformational thing. But I place a lot of stock when I read a paper or I see a talk in how that intro is structured. It's kind of like, the what's the story of, what band was it? The purple M&Ms or the blue M&Ms? I can't remember. Like, like the one of the big rock bands always had in their rider.
Oh,
we
right.
must have blue M&Ms in the green room, and like a lot of people talked about it as like a really like a diva kind of thing. Like they're just putting like random shit in their contract requirements because they can, because they're famous. But it actually was not that. What it was the stage setup for these big stage shows are a pretty big thing. And if you don't have attention to details, shit falls and people get hurt. So when they went to a venue and there were not blue M&Ms on the table, They were like, the person hasn't been detailed and meticulous with reading our requirements.
Van Halen.
And it was Van Halen. Yeah, that's right. Yeah. And so for me, the intro of a talk is similar. Is if the person is taking the beginning of the talk and saying something rote, just saying what everybody else is saying, they haven't given the thought to what's unique about their work. I start wondering what other places have they not been thoughtful. And so I feel like often when I'm reviewing a paper, there's a pretty strong correspondence between the level of insight in the intro and the quality of the paper. And the same thing when I hear a talk. If a student is up there and their intro is something I've heard before from many people in the field, I'm like, okay, perfectly fine intro. They're a new student. When that intro is something that I haven't heard before, I'm like, that's coming from them. This is a thoughtful person. I'm quite interested because I want to know what else is there. So I put a lot more stock on that intro than I think a lot of other people do, but it is a little bit of the canary in the coal mine to me.
I'm on the same page.
I think everybody should go have some dinner.
Yeah, let's call it here. Thanks, Kayvon.
I think everybody should go have some dinner.